Okay, good afternoon and welcome to Grade 8 Coding. Excuse me. It is the 8th of July today and we are doing loops with Ray and BB-8. Okay, just quickly have a look at all that I need to have a look at. That seems fine here. You guys just crack me up in this chat box. From the longest English word apparently to sirs all of a sudden. You don't even know my size, but you are greeting me as if I am a plural. Anyway, I'm just glad it's not English because I don't want to be struggling with those long words. I'd rather focus on computer code. Right. Okay, so that's enough trash talking for today. We are going to run through this very quickly. We'll finish the last puzzle for the previous lesson. I don't have it on the slides here because I just didn't feel like adding it on there for one single puzzle. But before we can continue, there are a few ground rules that I have to set just in case we have some new attendees with us today or participants. And for those that are watching the YouTube recordings, when they do come here, they can know what to expect. So first up, if you are watching a recording on YouTube of these lessons and you would like to come and join us in the live lessons, you can head to the video description down below. There are some links there where you can sign up if you have access to an email address. If you do not, then you can get a parent to sign up on your behalf and just register there, receive the links, and then come and join us in the live lessons, okay? We do require registration just so that we can try and sort of manage some sort of control about who is in these lessons and who we don't want here. So that being said, if you do make your way to these lessons and you have access to the chat box, I do expect some things from the participants. The first one is to keep the chats relevant to what you see on the screens. Obviously beforehand you can say hello and you can do whatever you want to do, but I'm lying, not whatever you want to do. Whatever is acceptable to do in a learning situation like this, you can chat that into the chat box. But once we start the lessons, I would like for you to keep the chat box clear so I can share links with you and so that I can see if there are any questions, right? Some classes have asked me a lot of questions with regards to binary code, what career paths you can pursue, all of those types of things. So for that reason, I need the chat box to be relatively clear, as well as keep your video cameras off. If you switch it on, I cannot see the screen, okay? And as long as you are chatting with me or anyone else in this chat box, I expect you to keep it respectful. I respect you enough to treat you in a good way, so I expect you to respect me enough to return the favor. Okay, if that is something that you cannot adhere to, then you can just catch the recordings rather than be here with us in the live lessons. Okay, so I'm going to move on. That's enough of that. Today's quote is from Bill Gates, the co-founder of Microsoft. Learning to write programs stretches your mind and helps you think better. Creates a way of thinking about things that I think is helpful in all domains. So what he's basically saying here is, if you take programming and coding down to its base level, what we are as programmers is we become problem solvers, right? That is why computer programming exists. Computers were created to solve problems. This is the class. Okay. Thank you for reminding me. There was one day when I recorded my lessons and I couldn't get the chat. I don't know, I did something wrong. So I wasn't sure who asked to what subjects you need to study to become a web designer. So thank you for reminding me, and sorry for not having gotten back to you. I still meant to ask my classes, so it was you. I'm going to make a note of that now so that I can get back to you with regards to that. Okay, So sorry I don't have that yet, but I will give you those answers. Yes. Okay, now I remember. Cool. Thank you for reminding me. I will definitely do some studying on that. We've just had a couple of meetings this week and so on, but we will definitely, I will definitely work on that and get back to you. So yes, guys, and please, if you ask something and you see that I don't get back to that, remind me, okay? I have a lot of things going on. I do quite a bit of work for the school, not only the teaching. So if I do forget some things, I'm only human, I make mistakes. So just let me know, and then I will try to remember for next time. Okay, so anyway, where was I? Okay, we become problem solvers, right? That is why computer code was created, why computers were created in the first place, because there were some problems that we were struggling to solve effectively. So we developed these systems to do it for us. Now, if you take into account that problem solving workflow that we discussed last week, that is a way of thinking about not only computer programming, but about everyday situations and problems that we face that you can actually start to apply anywhere, right? So the way that we go about solving problems on a computer, that's the same way you can go about solving problems in maths or solving problems that you might have with a sibling, even life problems you can solve in that way. Okay, so this is why Bill Gates says it creates a way of thinking about things that I think is helpful in all domains, right? He's obviously applied that same method of thinking to building an empire and a massive business. Okay, so that's just something to think on. Right, so these terms we have to know. Now, I'm mentioning these terms now, although we're not working on these things yet, but I know what's coming. So I want you to at least start thinking about these, and then if you have some extra questions about them, you can start to research them on your own and see if you can gather some information about these that I mentioned here. So the first one is a sequence. We saw it yesterday for the first time, but I've been mentioning it from the beginning. And it is the main, the main logical structure of algorithms or programs. So when we say programs here, we also mean games and apps, okay? It's the same thing. So the logical structure, what that refers to is when we take a few lines of code or blocks of code in our situation, we put them together, we create a sequence. Now, there isn't a clear definition out there of what exactly a sequence is. A sequence consists of 5 blocks or a sequence consists of 20 blocks now. The way that I approach it and the way that I structure it for myself to make it logical and easy to understand, I take a sequence as being that segment of code that performs a single function or action or calculates a single value, okay? And that is also the way when we get to comments, we will get there eventually, and we start applying data. I insert the comments into my code so that I know what each section or sequence of code does. That way, when I come back and I have to debug or a next person is working on my code, they can very easily identify what each sequence within the program does. Okay. Now, in my definition, a sequence can be 20 blocks or 20 lines long, or it can be 1 block long. It is all going to depend on the application that it is being used for. Now, keeping that in mind, we can have a look at conditionals. Conditionals is the if and then logic statements that changes the way that the code is executed, okay? So what that means is if we have a sequence that says, thinking of our example now here on code.org, move forward, turn left, okay? So that's a sequence, 2 blocks, move forward, turn left. So if we run that code, it doesn't matter what the maze or the play area looks like for that character. The code is going to try and run. It is going to try and execute, and it is going to try and force the character to move and turn left because that is what we told it to do. But there might be some situations where moving forward and turning left is not going to work. and where we would want to move forward if a certain thing is in a certain way, and where we would want to turn left in another situation. So this is where conditionals become very useful. What a conditional does is it tells your software and your code to check if a certain condition has been met or not before executing code or before deciding which one to execute. Okay, so when a certain condition is true or false, it has been met or not. And sometimes the condition is false, and then once it's true, the code executes. So it all depends on the conditional that you are using. So you can say, if there is a path, then move forward. Okay. If there is not a path, in an if-else block, so if there is a path, move forward, else turn left. So that is an example of if you had no path ahead, but there is one to the left. Okay. So you'll see that in a more practical application once we get to using them in our actual code. So here's the homework lesson from yesterday. I didn't receive any feedback on this. If you did send me, I did receive an email without a photo attached. It said photo with no attachment, but the names that I see here in the chat box and in the participants tab doesn't always relate to the email, the names on the emails that I receive. So if you did send it to me and I missed it, sorry. If you didn't send it to me, that's also fine. So there were two ways of doing this, and what I want to do actually is to jump into this before we move on to the next lesson. But you can see that I did this in 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, 7 blocks, not counting the when run block. Okay. So what I did is I did the first square, then I jumped to there and I did the second square. Right. So today we want to jump into BB-8, but before we do that, we just have to quickly finish this lesson 10 or puzzle 10. Give it a second to load. So puzzle 10 is just a question. Nothing tricky about that. It's actually a good one so that I can read this while you guys navigate to the link. Just do me a favor and type a yes in the chat box if you could actually access the link. Sometimes there are some problems with the links and I don't know if you don't tell me. Okay, good. Thank you. Look carefully at the code below. What will happen when you click run? So we use the process of elimination by checking this. The artist will draw a triangle with 3 equal squares. That's the first one. Just looking at the code, we can see there are 1, 2, 3, 4. I'm saying squares, signs. There are 1, 2, 3, 4 signs. So we can already say that A is wrong. Okay. I've selected it now because I highlighted it, but A is wrong. By the process of elimination, we can see that one will not work. The artist will draw a single line. So B also has to be wrong because we can see that there are 4 lines that will be drawn. D says, I don't know. That's never an option for us to choose because we are programmers. We need to figure it out. We need to solve the problem and we need to find out what will work and what won't. The last one says the artist will draw a square. So I see 1, 2, 3, 4 lines, but I see only 1, 2, 3 90-degree corners. So just looking at the code, it might seem confusing because we know that a square or rectangle has 4 90-degree corners. But I'll show you now why there are only 3 in the code. But by the process of elimination now, we can verify what we expect here. So I expect it is going to be a square due to the 4 lines of equal length. But I am doubting that expectation because of there are only 3 90-degree angles here. However, using the process of elimination, I have now verified that this has to be the only option that makes sense. So if we run it, you'll see it is correct. It is a square. And the reason why there are only 3 90-degree angles is because of where he started and where he's finishing. He's creating a 90-degree angle without us having to code it in here. Okay. So does that make sense? Are you ready? Can we move on? Yes or no? Okay, good. Right. So let us, I have one yes. I'm going to jump into that homework puzzle. I want to just talk on this for a quick second. Okay, so I hope all of you have tried this, because I'm not going to explain the entire thing. I just want to explain that there are different ways to do this, but I want to also show you. So what I decided to do was to move forward and then to turn right by 90, obviously moving forward by 100 pixels because that is how long the squares are. They tell us that at the top. Then I'm turning right. So this, I decided to repeat that twice. No, I'm just trying to think here. 4 times. Let's run that. Yes. So I repeat that 4 times in order to draw the first square. Now I want to loop this loop, right? So I want to do a nested loop. So that nested loop, for that to happen, I want him to not be there. I want him to be there, but I don't need him to draw that line again. So I just make him jump forward. And when he jumps forward, I can say, okay, let's repeat this code, the entire loop twice. And if I run this now, you'll see he jumps forward without drawing that line. But what I want to show you is if we set the color here, was it here? Let's just test this quickly. Okay, yes, there you can see. So now it becomes visible that he did not draw that line because he's jumping after the set color block has been chosen. Okay, so it becomes obvious that there he's not drawing a line. But if you do it this way, then you are going to have this line covered by that. If you want this line to be black and you want these 3 to be red, then your code will have to look different. Okay, so this is an example of where we always strive to make the code shorter, but shorter code does not justify not reaching our intended goal. So if you have a look at this, this is the shortest way to create this code that I have tested and found. But if our goal was to have this a square and only those 3 red lines and the first square to be black, then it would have been justified to use longer code. Okay, so you need to always be aware of that. Just for having shorter code does not outweigh reaching a preferred outcome. Okay, if the client wants something specific, your employer wants something specific, and it means you need to create longer code to reach that, then you have to do that. There's just no other way to work around that. Okay, so I know in these lessons we always try to go and challenge ourselves to get the code as short as possible, but it's not always what is needed, just short code. Sometimes it's needed to create longer code in order to get what you need there. Okay, does that make sense? I see there is a no, so I just want to go back to this one here because that is what the no was for. So if we look at this code, I'm going to run it so that we can have a visual representation as well. Review the code. Please don't jump. Oh, come on. Sorry, I was trying to make the play area bigger and then I selected. Okay. Review code. Good. So here we had, when the artist was there facing down, we drew a line by 100 pixels. Then we turned left by 90 degrees to give us that first corner. Then we moved forward by 200 pixels there. Then we drew a 90-degree corner there. That's that second 90 degrees. Then we moved forward there by 200 pixels. Then we drew that last 90-degree corner there. Then we moved forward by 200 pixels again. Now we didn't have to create code here to draw a 90-degree corner on this corner, right? Because this starting point, he was facing down. And in this ending point, he's facing this way. So when the two squares actually, not the two squares, when the two lines meet up with each other to close, it automatically creates a 90-degree corner. Think of it the same as you drawing a square on a piece of paper. You're not drawing all four corners physically. You're just connecting the lines, right? So this one works the same way, except that here he's doing them in a sequence from doing that, then this, then that, then that. Okay, when we draw a square, you can do that, and then the bottom one, and then the two sides if you'd like to. Okay, we can do that with the code as well, but this is now obviously a fixed code that they gave us. Okay, Ameling, does that make sense to you now? Do you understand it? Are you happy with that? Good, and is everyone happy with the bonus level? So can we start looping with BB-8 and Ray? Okay. Just going to continue. You can watch the videos if you'd like on your own screens. So I'm a big fan of Star Wars. For those of you that didn't know that, yes, it's the typical thing. I'm a Star Wars fan. I do not like Star Trek. Strange, I know, but it just does not tickle my fancy. So I enjoy this lesson, but I have to honestly tell you, this is an extremely easy one. So we can really fly through this. But the reason why it's there is because we are practicing using these things, right? The repeats. And these are all repeats where we set the amount of times that we wanted to repeat. So we can choose how many times the sequence will loop. But we need to understand these ones very, very thoroughly because, as I showed you in the beginning, we spoke about conditionals, right? There is something that's known as a conditional repeat. That means it is a repeat that will only happen as long as a certain condition is false. So it will repeat until something is true, or it is going to repeat while something is true. So there is a repeat until and a repeat while conditional loop. But that won't make sense at all if you don't understand this basic repeat first, and understand that you can put repeats in repeats in repeats if you want to do that. Okay. So these puzzles of loops, they might be easy, but they are very important, okay? So I'm going to do the first one, and then from there on out, I want you to assist me. The only reason I'm doing the first one is so that you can see when we did the collector, programming in collector, we had to say collect in order for the collector to pick up the gem. Excuse me, for this, BB-8 only has to move over that. So we're going to say move forward there. And we have to do this 1, 2, 3, 4, 5 times, right? Because use 5 of the same blocks to get the scrap metal. Okay. So they're saying use 5 of the same blocks because they want to show us the difference between not using a repeat and using a repeat. But now we already understand the difference. So that is a more efficient way of doing it. Okay, just stick the move forward in a repeat times 5. So does that make sense? Can I move on? Okay. Okay, and now, so that's why they wanted us to use 5 of the same blocks, because they want to demonstrate what would happen if you put it in a repeat. So just choose one. I'm not going to discuss this. It should be straightforward enough. Give me the answer, A, B, C, and never D. Oh, excuse me, guys. Okay. Right, so let me just skip this video again. There we go. Okay. Now we need to collect all of this scrap metal. Pro tip, BB-8 is already facing that way. He's not facing this way, he's facing up. So what do I do to collect all of that scrap metal? You tell me. Lesedi, he is already facing the scrap metal. See? So we don't have to turn anywhere. Yes. Cesar in the private chat told me to move forward in the repeat block. How many times? I would wonder. 5 times. Cesar, yes. 1, 2, 3, 4, 5. Okay. While we're here, I need to very briefly explain something. If you set this to a high number, 10, and you run the code, it's still going to work because this puzzle has been set to terminate as soon as the goal has been reached. But I would like you for now to practice using an accurate amount of repeats. The reason is in some of the later puzzle that will be coming, they do not self-terminate. Even if you have reached the goal, it will not stop. The code will keep running. And if you are using turns and things and there's nowhere for the character to go, you will receive an error here at the top telling you that your code isn't right. But you are doing everything you're supposed to be doing. You're just repeating one too many times. Okay. So again, without trying to offend anyone, if you have used a higher number for this puzzle, you are still right. I just know it's coming. So I try to guide you to get your thinking sorted from the beginning and focus on getting the repeats accurate. Okay. So that's an easy enough one. Can we continue? Yes or no? In this puzzle, 2 repeat loops will help you to get all of the scrap metal. So, how are we going to do this? Repeat, move forward times 4, yes. And then? We have a problem. There's only a turn left block for us to choose from. So what do we do now? There we go. Change it. Yeah. Just then move forward times 6. Okay. So this is just, I just want you to keep in mind that where you see these drop down arrows, that means that there is a toggle. Lesedi says times 5. Yes, Lesedi, that's right. 1, 2, 3, 4, 5. So just to show you here, we are already on that block. I'm going to move this out. Come on. So we're already there. So we only have to move 1, 2, 3, 4, 5. I constantly make this judgment error here because I count that one. 1, 2, 3, 4, 5, 6. But yes, only 5 are necessary. 6 will not be wrong. Six will still reach our goal. Okay. We can continue. The further we get with this, the better. So I don't mind if we go over what we said we're going to do. Okay. This one. Another pro tip, he is facing down. You only have 2 move forwards and 5 blocks. The chat box is yours. Tell me where and what you want me to do. Move forward, yes. No problem if you're late. Thank you for telling me so that I can drop the link for you. Welcome. Okay, after we've turned right, good. Are you all happy with this one? I know these seem easy and almost like a time wasting exercise, but we have to practice using these loops often, and we have to use them in different scenarios. Okay. We need to add but one block onto this to complete this puzzle. What block is that? Yes. How many times? A repeat block so that we can loop this sequence. How many times are we going to loop this? Times 3. Test it. Can we continue? Okay. This one tripped us up a bit in the grade 9 class. So I want to see, not them, me. I was the one who got confused on this one. So I want to find out from you, how would you do this? We have only 6 blocks that we can use. So technically only 5 because one is already used by that and we cannot take it away. So what do you think? Some people look at this and they see the pattern immediately. Other people, like myself, I had to take a second and a third look before I could identify the pattern. But there is a pattern there. And Amuling has it. Move forward, turn right, move forward, turn left, test it before we loop it. Now I'm like, that's not your mistake, that's mine. I wasn't paying attention. Okay. Now we loop it. 5 times, they say. We'll see. And 5 times are correct. So I just want to show you something here. What caught me up earlier, well done to you guys for getting this the first time. What tripped me up on this one was I wanted to move forward, turn right, move forward twice in order to be aligned here. Because this is also a pattern, right? You can see that. There's a bigger pattern where this one is a smaller step pattern. That one is a bigger step pattern. The problem with that is it forces you to use more than 6 blocks. You cannot do it under 6 blocks following the larger pattern. Doesn't matter whether you nest repeats or not. It doesn't change anything. If you want to follow the larger pattern, then you have to use more blocks than 6. So if you follow the smaller pattern that you saw immediately, then you are using only 6 blocks. Okay. Are you good to go? Can we continue? Okay, so this is a challenge puzzle. How would you go about doing this? Move forward, yes. Perfect. That's always a good start. Turn left, okay? Okay, so first this, and then we repeat it. Some are saying 5, some are saying 6, so let's just test that first. Okay, so 5 seems to be doing it. This is one of those examples if we accidentally create it too long, then it's going to throw us off. Okay, so how do we end this? We're finishing here, facing here. Okay, like this. Aha, Lesedi says move backwards. Okay, so there are 2 ways to do this. The first one is to turn left twice so that we turn around. Then from here, move 1, 2, 3, 4, 5 forwards. Okay, and then we are finished with this puzzle. But there is a shorter way to do this. Oh, goodness me. This has to be changed to 5. Okay. So now we can see we're turning around and we're doing that. That's good to go. But we can do this and remove 2 blocks by toggling this to backwards. BB-8's body is a ball, so he can obviously move in any direction that he so pleases to do, or that we tell him to. Okay. So this repeat here, this is now where I would call this a sequence. Okay, and if I had the ability here, we don't have it now, but it will come later, I would put a comment here to say step pattern, and then over here I would call this last row or whatever, and then put this in there. But just to make sure that I could separate these 2. So here you can see, excuse me, you have a sequence 1, 2, 3, 4, 5 blocks. Here we have a sequence 2 blocks long. So, and this is how I define sequences in my definition, to separate sequences and make sure that I am adjusting the code to where I need to. The reason why I approach it that way is so that if I find a problem here, I'm not going to mess with this code. I'm just going to move it out of the way, make my adjustments, put this back, and then I know I'm good to go. Or the other way around. If I know that the problem is there, maybe we're moving too far, we're not moving far enough, I'm not going to play with these settings here. I'm just going to adjust that code there. Okay. But yes, this move backwards is also a viable option, as well as turning around. So again, it all depends. Sometimes we do not want to turn around. I'm lying. Sometimes you wouldn't want to go backwards, so you make a turn around. Right. Are we good to go? Can we squeeze in one more? We have 6 minutes. Okay. Okay, so this one, we need 11 blocks. Or we have 11 blocks, okay, that we can use. So actually only 10. I've dissected this puzzle every which way, and I cannot find an obvious shorter way to do this. So we just have to go the long route. We're going to move forward twice, turn right. Then from here, we're obviously going to move forward 1, 2, 3 times. So now we can use a repeat. Remember, when we repeat the same action 2 times, to use a repeat doesn't make a difference in the block count, okay? There we're going to turn right again. Now we're there, so we're moving forward 1, 2, 3, 4 times. Set this to 4. Move forward. And then over here, we're just going to turn right. There's something in the way. Where do you mean? Oh, come on. Oh, yes, you mean to make it shorter than 11 blocks. Yes, there's no way you can make it shorter due to the fact that there are some things in the way there. I think that's what you're referring to. Okay, so you can see here, we're repeating the same action twice, one single action twice. So we do it, we can just place 2 blocks. We don't have to put this in a repeat times 2. You can if you want to, but if you have a look at our block count, you'll see that it is still using the same amount of blocks. That's 3 blocks used, and this is going to be 3 blocks used, but without having to fiddle with any of the settings, okay? So we can see this one is advisable to use a repeat, because if we want to move forward 3 times, we're going to have to use 3 blocks, where now we're only using 2. Okay. I want to check something here quickly. So I'm going to leave you with this as a homework challenge. For those of you that want to, you can share it with me. So the goal is to collect 5 pieces of treasure, right? So there's an easy way. You can just move forward and collect 5 times, because there are 5 blocks. So that's going to give you 5 treasures, okay? Good, happy. Another way to do this is to just move forward once and then collect 5 treasures on this place, 5 gems. That's going to be 5. But what I want to challenge you with is to try and collect them all within the 16 blocks. Then if you'd like, you can share that to my email address, which I will show to you in a second. Obviously, tomorrow, we're not going to start from number 9. We're going to start wherever we left off, which I think is 12. And then we will just carry on to the next lesson, which will be loops again, but a different application, okay? So there's my email address. Thank you so much for being here today. Thank you for participating. You can send me the homework if you've completed it and you would like to do that to that email address. And then you can find us on Facebook, Instagram, Twitter, using or searching for Africa Team Geeks. And I will remember to do some research on what you need to have with regards to your subjects if you would like to study web designing. Okay. Have a great day, and bye-bye.